We live on a planet that's literally covered in water, right? So how is it possible that billions of people don't have enough to drink? It doesn't make sense. Today, we're diving into the paradox of freshwater. It's a story of scarcity, pollution, and some pretty incredible engineering that could be our way out.
All right, here's the game plan. First, we're going to dig into the surprising truth behind our blue planet. Then, we'll get real about the twin crises threatening our very limited supply. But we're not going to stop there with the doom and gloom. We'll see how engineers are fighting back, we'll witness a stunning real-world transformation, and finally, we're going to completely flip the script on what we even think of as waste. Let's jump in.
Okay, so we all learned this in school, right? Earth is the blue planet, the water planet. And yeah, it is. But that simple little fact, it hides a really startling paradox.
I mean, look at it from space, and it's just this big blue marble, an endless ocean. But the water we actually need, to drink, to grow our food, to run our industries, well, that's a whole different story. So let's ask the big question. Out of all that blue, how much can we really truly use?
Okay, I want you to try and wrap your head around this analogy, because it's a big one. Imagine all the water on Earth, oceans, glaciers, the whole shebang, could fit into a 100-liter barrel. The amount that's fresh and accessible for us to use? Just half a teaspoon. That's it. That's everything we have to work with.
And if you want the cold, hard number behind that teaspoon, here it is. Just 0.014% of all water on Earth is readily available in our lakes, rivers, and groundwater. It is this unbelievably tiny, precious fraction that has to support all life on land, us included.
Okay, so keep that tiny fraction in your head. Now let's talk about the immense pressure we're putting on it. And this pressure, it's really coming at us from two sides. Our demand is just skyrocketing. And the pollution we're creating, well, it's making things so much worse.
Think about it. Our global population is growing and moving to cities at an incredible pace. By 2030, and hey, that's just around the corner, our demand for water is projected to jump by a massive 50%. And most of that squeeze is going to be felt in our cities.
So you might be wondering, where is all this wastewater even coming from? Well, this breakdown is kind of revealing. Agriculture is the absolute giant here, responsible for a whopping 70% of both consumption and the polluted drainage that comes with it. But, industry in our own homes, we're definitely adding a pretty significant burden to the whole system too.
But here's the real kicker. It's not just about how much water we use, it's what we do with it when we're done. A truly astonishing 80% of the world's wastewater gets dumped right back into nature completely untreated. And the human cost? It's just devastating. We're talking 1.8 times billion people forced to drink contaminated water. That leads to diseases that kill nearly 850,000 people every single year.
And this is where it all starts. In so many low-income communities, there's just no proper sanitation. Human waste is discharged directly into open drains that run right through the middle of neighborhoods, turning public spaces into, well, major health hazards.
And hey, it's not just household waste either. Natural canals, which are supposed to carry clean rainwater, they get hijacked. They basically become open sewers. I mean, you can literally see it here. Industrial waste dyed with who knows what chemicals, mixing with raw sewage as it all flows directly into the local ecosystem.
Wow. Okay, so this all sounds pretty dire, right? A tiny supply, huge demand, and a massive, massive pollution problem. But this is exactly the kind of challenge that led to the rise of a very specific field of expertise, environmental engineering.
I love this quote. It just nails the difference. Scientists discover how the world works, right? They're the ones who identify the cholera bacteria or measure how toxic a chemical is. But engineers? They're the ones who take that knowledge and build the actual solutions that keep us safe. They make it work.
So, what is environmental engineering, really? Well, at its core, it's all about applying science to build a healthier world for everyone. It's the discipline that's laser-focused on giving us clean water, air, and land. And just as importantly, figuring out how to clean up the messes we've already made.
This field didn't just pop up out of nowhere. It really grew out of pure necessity. Back in the 1850s, you had people like Dr. John Snow proving that contaminated water caused cholera. And boom, that gave rise to the first sanitary engineers. Then fast forward to the 20th century, and you have these shocking events, like a river literally catching on fire, and game-changing books like Silent Spring. That's when the focus really expanded from just human health to the health of the entire planet, and that's how we got modern environmental engineering.
Okay, so that's the theory. But what does this actually look like in the real world? For that, we're going to head to Dhaka, Bangladesh for an absolutely incredible story of transformation, the Hatirjheel Restoration Project.
So, this is Hatirjheel before the project. This whole network of wetlands, it was supposed to be a critical part of the city's drainage system. But as you can plainly see, it had basically turned into a polluted, clogged-up wasteland, a serious public health hazard instead of the public asset it was meant to be.
So what exactly went wrong here? Well, the problems were pretty huge. You had untreated sewage and industrial waste being dumped right into the water, you had illegal construction just creeping in and filling up the wetlands, and eventually the whole system got so choked with pollution and garbage that it just couldn't handle stormwater anymore. The result? Massive, citywide floods.
And now, look at this. This is the result. Just take a second to absorb this transformation. The before is a polluted, clogged-up mess. And the after? It's almost unrecognizable. The engineers and planners, they didn't just clean the water. They reclaimed the land, creating this stunning public space that has become the new heart of the city. This is the power of environmental engineering in action.
So what did this actually achieve? Well, the project reversed decades of environmental damage. It restored the area's natural ability to prevent floods, which helps protect the whole city. And it went beyond just cleaning the water. It created amazing new recreational areas and even transportation links, which helps ease traffic. I mean, it was just a massive win on every single level.
You know, the Hatirjheel project is incredible, but it also points to a much, much bigger idea. It's about a fundamental shift in how we think about the stuff we throw away. It's about looking at what we call waste and seeing a hidden opportunity.
This right here is the key idea. What if we stopped looking at wastewater as a problem, as a burden to get rid of, and instead started seeing it as a really valuable resource that we're just throwing away?
Just think about the sheer scale of this potential. The wastewater from a single city of 10 million people, get this, it contains enough valuable nutrients to fertilize 500,000 hectares of farmland. That could produce 1.5 million tons of crops. And that's not even counting the water itself. That can be treated and reused for everything from irrigation to industry.
And here's the most important part. The science and engineering for this, it already exists. We have the ability, right now, to turn a dangerous liability into a powerful asset. By treating wastewater as a resource, we can fight water scarcity, we can improve food security, and we can build healthier cities for everyone. It all just starts with a simple shift in perspective. Which leaves me with one final question for you. If polluted water isn't waste, what other valuable waste are we overlooking?